So in these examples, let's actually compare what happens as we change compounding periods. So for this one, it says find the amount to which 1,500 will grow at simple interest. And remember, our simple interest formula is just A is equal to P times 1 plus RT. And here my P is, I'm putting in 1,500. And I know the interest rate is zero point 0, R is equal to 0.0675. And my T here is equal to 10. So when I calculate this A, this ending balance, I'm going to get this here, 1,500 times 1 plus 0.0675 times my T, which is 10. And so again, I'm going to work this part first. And when I do that, I get 10 times 0.0675, which is 675. So I get A equal to 1,500 times 1.675. If I multiply 1,500 times that 1.675, I get 2,512. I get $2,512.50. And so notice here, if I started out with this amount, $1,500, after 10 years at this particular rate, I've grown to this amount. So in interest alone, which is I, in interest alone, we just take this value and subtract it from the original value. So minus 1,500. And I can see that in interest alone, I've gotten $1,012.50. So that's it, annual interest compounding. Compounding one time a year. Or simple interest, that's what it literally is. So now we're going to compound it over quarterly payments. Look at quarterly payments this time, all right? And so when I look at it compounded quarterly, the new formula I'm going to use is A is equal to P times 1 plus R over N, because I'm compounding, raised to the NT. So A is equal to 1,500 times 1 plus, my R is still 0.0675. But I'm going to divide that by my quarter compounds, which is 4. I'm going to raise out that to the 4 times the T, which is 10. So again, I'll work everything inside of here first. And when I do that, I do 1 plus 0.0675 divided by 4. I get A is equal to 1,500 times. This becomes 1.016875. And I'm also going to calculate this part up here, 4 times 10, that's raised to the 40th. And so when I raise this number inside of here to the 40th power, I get A is equal to 1,500 times this new number when I raise it to the 4 is 195,300,2554. And if I want to solve for A now, just multiply that number by 1,500. And I get A equal to $2,929.50. And again, if I want to calculate the interest that I've gained on that compounding quarterly, I just subtract that from 1,500. And I see that my interest, I, is equal to $1,429.50. So if you notice here, when you compound it quarterly, you got almost $400 more than when you did it like that, when you did it simple. And then the last one says, well, let's compound it even further. Let's compound daily. Let's do it every day. So again, we know our formula is A is equal to, we're going to use the P times 1 plus R over N raised to the NT. So A is equal to 1,500 times 1 plus, my R here is 0.0675, divided by my N, which this time I'm compounding daily. So that's 365 raised to the N, 365, times the T, which is 10. So this time when I calculate 1 plus 0.0675 divided by 365, I get a very small number that's bigger, a very small number close to 1. So that's 1,500 times, and I get this number here, 1.000184. 0.4932. If you compare this number right here to this number when we compounded quarterly versus when we compounded annually, notice that this number right here is getting smaller. This growth rate is basically getting smaller. It's getting smaller, but it's going to occur more often. Because now if I do 365 times 10, I'm going to have 3,650 compounds occurring in this particular period. So when I take that number that I just got right there, and I raise it to the 3,650th power, I get this number here. So A is equal to 1,500 times 1.96391041. I'm going to multiply that times 1,500, and I get a value of $2,945. And so A is now equal to $2,945.87. And again, if I want to find I, if I want to find my I here, I just subtract off that 1,500 that I started with. And here, notice my I is, my interest that I've gained on that is $1,445.87. So notice that as I compound more, I'm going to get more interest. I'm going to gain more interest. So the more I compound, the more I gain. And that's how we do these problems here.